Okay, you guys. Okay, so I'm streaming now. Um, so what we're gonna do is we're gonna talk about power series still. Now Taylor series, I'm gonna talk about more. Now remember, this is understanding today. So one thing you need to understand is I can take a derivative and integration of a power series. Okay.
But we can't.
We can take a derivative. So this so you can take a derivative or integration of power series. Okay, so what do you mean? It means what is power series? So supposedly there was a function. It's always represented by this power series. It's n equal to 0, infinity of a n times x minus c to the n. Supposedly I have this. And this is equal to, if I write out the series, is f of x equal to a0 plus a1 times x minus c to the first power plus a2 times x minus c to the second power plus a3 to the x minus c to the third power. And of course, I keep on going. What if I decide to take a derivative? If I take a derivative of the left side, what's derivative of a0?
0.
0. What's derivative of a1 times x minus c?
1 over x minus c.
A1 x, that's it.
Oh, it's just
the c will go away. If you distribute it, it's a constant. How about derivative of a2 x minus c?
We have to channel or no?
Yeah, you do channel, but it doesn't matter because the inside is x minus c, so it's times 1. So it'll be 2 times a2 times x minus c. Is that okay? 3 times x a3 times x minus c to the second. Does that make sense? Can I write in general term? So that's, can I write as f prime of x in terms of summation mark?
Yeah, can you do like
n equal to?
n?
Do I start with a 0 or start with 1 first? You should start with this one, right? So what is the 1? So because a to the 1, right? So 1 to infinite, right? If I take it, this is a 1, so this is going to be a to the n. Does that make sense? But this is a n equal to 1, this is n equal to 2, this is n equal to 3. So that means, see this 2 and this 2 are same, 3 and 3 are same. So it's going to be n times x minus c and minus 1. Thank you. So the derivative is automatically becomes this. So you can take a derivative power series. It's going to be exactly look like this. The only thing is there was a change from n equal to 0 to n equal to 1. Am I going too fast? That's it. Let's take a derivative of the f of x. So if I take a same f of x function, right? If I say, hey, let's take a derivative of this, I'll take integration. So let's say if I integration of f of x instead of derivative, so I can integrate this. And what happens if I integrate a0?
You get x.
a0x, right? What happens if you integrate the a1 times x minus c to the first? Well, a1 x minus c, it's just like x instead of x minus c, so it's going to be 2 over 2. It's like how you take integration of x squared. Plus a2 of x minus c to the second. Not to the third, sorry. Over 3. Plus a3 times x minus c to the fourth over 4. So can you tell me what is the general expression of this? Let's practice. Do I start with summation at which number? N equal to what? No. 0. To the n, right? To the infinity, sorry. N equal to 0 to the infinity. What will be the first? What will be the general expression here? A sub n times what? N plus 1, right? Over n plus 1. I forget something. What do I forget?
No.
Yeah. If I integral, I always have what?
Plus C.
There we go. Plus c here. No, that c and that c is a little bit different. C is the center where C, this C is just another constant. So don't forget if you take integral, so don't forget this one. Now for some of you guys a little bit, if you are becoming more advanced student, that you according to the professor, he says, depending on if you integral or derivative, if you integral, you might lose one of the endpoints. No, if you take a derivative, you might lose one of the endpoints of the convergency. Now, if you integral, you might gain an endpoint. Now, it says this part is not always tested all the time. It will definitely not tested on AP level. It will probably test it only if the higher level student at the universities. So in the AP level, don't have to worry about this, but I still just have to mention, I'm going to say that again. You might lose one of the endpoint of the convergence due to the derivative of the power series. Or you might gain an endpoint when you're doing integration of power series. You might gain one of the endpoints due to integration. Now the actual reason, I have no idea why, so I won't. But that just say he says something that sometimes it could happen in the college test, but definitely not AP level. AP doesn't even explain all this in that much of detail. Now, we have to know this for sure. What's the only function you know represented by power series? X to the n is represented by which function? It's represented by which function? No. Which function represented by x to the n?
X to the X.
Almost, no. No.
X minus
You
A to the n.
no.
What function? That's the function. X to the n.
No, this is a power series. This power series represented by some type of f of x. What will be this f of x in terms of x?
I think it's X to like some sort of like power, and then that exponent's an X. There isn't it just X to the infinity?
No,
X to the X minus 1.
no. No. Go back, look at your notes.
Didn't Andrew make this part yesterday?
Yeah, Andrew's here, he will figure out. power series.
N factorial x to the
X to the n is represented by a function that you need to know.
Maria? It is?
It's on your notes.
Are we talking about
Alternating power series.
No.
General power series.
Are we talking about the like summation of a to the n of
Like,
x
I don't
minus
even know what's being asked.
the n?
Yeah.
Oh, that.
No. No.
Oh. A to the n x to the n.
Okay, fine. I'm gonna give you a clue. Geometric series.
Oh, you said nodes.
It's in your notes. I write this on
Like
when we
A over 1 minus r.
huh?
A over 1 minus r.
A over 1 minus r, but it's not a. Is the first term is 1. If you plug in 0 here, the first term is 1. One minus x.
Yeah,
Oh my god. Okay.
Okay,
that wasn't one.
I probably give you guys like by Wednesday extra credit. You had to remember 5 formula. This is one of them. This is one of the power series you have to know.
Yeah.
I'm gonna give you a second one using this one.
Okay.
So the next function that we're caring about is f of x is equal to natural log of 1 minus x. How do you get from here? Let's just say we're gonna call it that. What will be like? What kind of things, right? N equal to 0 to infinity of question mark. What kind of thing would it be? But let's think about it. If I have 1 over 1 minus x, what can I do?
You can divide everything by x.
No,
It's just e to the n. E or
no,
e to the n.
no.
I'm master of e to the x. Yeah. Well, that card just got revoked.
This is natural log, not e.
So let's just say, here's the question. Is it possible for me to represent a what natural log of 1 minus x in term of power series? In term of power series. And the clue is on the top. And clue is also title of this lesson.
So put
Not a derivative.
e to the power of negative.
Integral. Good. Can I integrate? So this is a question mark, right? We want to know what's the natural log of 1 minus x. Now, can I integral 1 over 1 minus x?
Yeah. Natural log.
And then can I integral this? I'm going to write this in terms of expressions. So it'll be 1 plus x squared plus x to the third plus x to the fourth, so on and so on. Then let's just take integral on both sides. Can I take integral of this? What would I get?
Oh, it's arc.
Natural log. 1 minus
Because the u substitution, it has to be this, right? If I integrate that, I'm gonna get this. Now, what happens if I integrate this? X plus x squared over 2 plus x3 over 3 plus x4 over 4 and whatever, right?
Students should now be back from A1.
But the problem is I didn't want to get a negative version of this. I want a positive version of this. So this natural log of 1 plus x equal to negative, right? X plus x squared over 2 plus x cubed over 3 plus x4 over 4 and then plus c. Because we integrate, you should get a plus c. So it is a plus c here. Now let's plug in one value that I know of. What's the natural log of one value I know?
1.
Natural log of 1. So let x equal to 0. So it'd be natural log of 1 equal to negative 0 plus 0 plus 0 plus 0 dot, 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 plus c. So therefore c must be 0. So therefore you just find your power series of this one. So that's ln of 1 minus x is equal to negative summation, well, I'm going to start with n equal to 1 in this case, right? X to the what? X to the n, right? Over what? Over what?
Just n.
Look, n. 1, 2, 3, 4, just n.
Don't think I forgot about what you did.
Does that make sense?
Yeah.
So we have two power series. Remember, this is a second one that I know of. And this one is the first one. You have to know this one. This is like the biggest, the baddest series that you need to know. Like the trump card of all trump card. It's like the,
The whole Trump.
well, I don't know.
Sharpening.
So this one, I will give you guys extra credit quiz, ask you certain series. And this is one of the series you have to know. Like some of you guys need extra credit to get an A. Some of you guys needed certain things, but I don't know how many points I can give it to you. But this is one thing I need you to memorize. This is another thing I want you to understand as well as memorize. So this is the second one. Now, we have a power series. Check. Yes. Okay. The next two series is super important. The next one is Taylor. Now, I don't really need to show you what happened here, but
On TikTok, on TikTok.
He sent me it. He was like,
one too.
he sent me TikTok. He was like, "Oh, lovely Calc AB," and then it was like, when I go to Calc BC, and it was like Taylor series all worked out, and it was like so much work. And it was confusing.
well, no, it's actually not. It's actually very, very easy. But I'm gonna show you what a proof is. Now, for example, like most of you guys taking AP Calculus, you just have to worry about how to use the equation. Now, if you really go to university, you can actually see the proof. Now, I'm gonna show you the proof right now. It's not like super important you need to know the proof, but I just want to show you where they come from. So the Taylor series is by this mathematician that Noah Taylor, yes, and then also there's a McLean as well. Maclaurin, yes. So Maclaurin is another one, but Maclaurin is, I think, it's kind of copycat, and then we're gonna talk about that.
Full players going on.
Yeah. So suppose, so we know this power series. Again, we're gonna write all the time the power series. Suppose we have power series of f of x is represented by a to the n summation of, sorry, not a to the n, is summation n equal to 0, infinity a to the n times x minus c to the n. This is the actual proof. Now you don't have to copy down in this part, but I'm still gonna show you. But this part, if you don't want to copy down, you're more welcome to take a picture of it. No, no one really need it, but this is gonna be happening. So here's this. I want to get to this part, a to the n. Okay? I'm going to explain to you why I need an a to the n. Because a to the n is a question mark as of now. And this is where the Taylor series is very, very smart at. So let's just say if I have a function, and this function is a to the 0 plus a1 times x minus c plus a2 times x minus c squared plus a3 times x minus c to the third dot 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 to the a to the n to the x minus c to the n. Now here's the point of interest. The point of interest is just like this part right here, a to the n. I want to figure out a to the n. How do I figure out a to the n by itself? How do I get a to the n by itself?
You have to distribute.
Derek might know.
E to the x.
That one.
No. Derek only know E. So how do I get to a to n? That means I need to kill all this term and stop right here. How do I do that?
Telescopic series.
No. You multiply by 0, everything go away. Oh, there's term after that too. So how do I get rid of all this term? Remember what we just learned. How do I get rid of all this term?
The center.
Huh? Derivative.
Ratio.
Derivative. How many derivative I need to take?
N.
Exactly. Because if you take all the way here, then all this will kill them. Gone. So you want to take the idea is you want to get an by itself. And an's right here because we have a0, a1, a2, a3, a4, a5 all the way to infinite amount of n, so until a to the n. Now, if I take n derivative, what happened? This will go away, eventually get to the a to the n. Why? Okay, let me show you how to go away. I'm glad you asked that. So I'm going to take a fourth derivative. So the first derivative I'm going to take, a0 is going to be what?
Because when you take 4 derivatives, it will become just a number. Okay, never mind.
Okay.
I'll follow.
So if I take a prime, what am I going to get? A prime is going to give me 0, right?
Yep.
This is going to give me just a1, right? And this is going to give me 2 times a2, right? And plus 2 times a2 times x minus c. And plus 3 times a3 times x minus c. And dot 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 to n a n x minus c to the m minus 1. Now that's only if I take the one derivative. I'm going to take a second one. What happens if I take a second one? This is going to go to 0. This is going to go to 0. This is going to go to what? To a2, right? Plus 3. This is second, I think. Yeah. 6, right? 3 times 2 times a to the 3. Wait, did I? This is 2, right?
Yeah.
Okay. So now 3, 2, a3, this is x minus c to the first, right? And whatever, if you go to infinite amount of time, it's basically n times m minus 1, right? Times m minus 2. A to the n times x minus c to the n minus 2. I ran out of space, but x minus c to the n minus 2. Now, hopefully you see this. This is something that's very important. We know that pattern. What is that?
Telescopic.
No, for God's sake. I was gonna say something, but I was live streaming, so I probably get canceled.
Just mute it. Mute your mic.
Yeah.
What
I
pattern?
won't. What pattern there? Oh, if you don't see it, we're gonna take.
Ratio test.
We're gonna take. For example, we're not gonna take to the
Oh,
third.
the factorial.
Thank you.
Yeah.
Look.
-1.
Okay, so if I take a fourth derivative, right? Just say I'm not taking n derivative yet. It's gonna be 3 times 2 times 1 of the a3, and then plus, right? Plus dot 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 to n times m minus 1 times m minus 2 times m minus 3.
Yes.
Yeah, so it's just gonna keep on times, and this is gonna be an to the x. I think there's x minus 4. I think it's x minus 4 here.
Yeah.
So basically, this part will change to what? To the factorial. So what happened is, if I take the nth derivative, if I take enough time, eventually that's going to be completely killing all this term here, right? And eventually you're going to have, this sums up as, you're going to have an n factorial of what? A to the n. Does that make sense? Of x minus c to the m minus n, because that's an n term. And if we take n term, this one's going to go fn to derivative is equal to n factorial a to the n, because n minus n is 0. Now, remember, our point of interest is to find out what the hell is an. Can I solve for an? So an is equal to and we're gonna plug in some number c. So this one's gonna be fn of c divided by n factorial. So we got the Taylor right here. Why is that Taylor? Because remember, that's power series. F of x is equal to summation of n equal to 0 to infinity an times x minus c to the n. This one you should know familiar. This one is the power series. Now, what Taylor series basically says, okay, well, I know what the a to n now. I take an n derivative to discover that new discovery, and this discovery is going to be in black, which is f n derivative to the c to the n factorial. We replace this with this. After we take n derivative, we find out what is a to the n, and that when that happen, that is going to be x minus c, which is everything rest the same, x minus c to the n, which is power series, but you have a coefficient that's in the front now. This coefficient, that is going to be cos, end of the day, it's going to be Taylor series. Like I say, you don't need to understand where they come from, but just seeing the development of it, you figure out what is in front of the coefficient. So for me, I don't remember that's a Taylor series. I just think about that Taylor series has a special coefficient that's in front, just like a power series, but we replace an with something else. It's fn of c over n factorial. Got it? Now,
The x minus c to the n part of the Taylor one?
yeah.
They're just replacing the a to that.
Yeah, we just replace that. That's why. So that's a replace. I don't know. Let's build replace. So replace with fn to the c over n factorial. This is the most important series. I will ask you to memorize this one. Remember, there are three right now. First one is 1 over 1 minus x. This is the summation of x to the n. Second one is natural log of 1 minus x is equal to negative summation n equal to 1 to infinity of xn over n. So the second one. The third one is Taylor series. Now remember, there's a Lauren. His name is Colin. Sounds like a white person.
Colin Rose.
Colin McLaurin. So he worked on a bunch of mathematicians with Newton, Leibniz, Euler, Lagrange, Wallace, and he's most well known as his Maclaurin series. It's very difficult to understand, so I need you to pay attention. How much time I have?
Like 6 minutes.
Good. I can use 6 minutes here. But no, I'm just kidding. I'm not gonna use 6. I'm gonna use 30 seconds. So Maclaurin says, hey, I can do better job. What if the center is not at C? What if the center is at 0? Then you're gonna have Fn of C over n factorial times x to the n. That's it. Done.
So it's just the same thing. Just put C.
Yeah, this is a Maclaurin. I don't know if I spelled it right. IN, I think.
I'll reopen it. I'll show Mr. Ye.
No, I will show you by Monday. I know what you're talking about. And that's the things I want to show on Monday. Is Taylor series, Maclaurin series. This is gonna be in place. So how many series I know? One is power series, which is x to the n is equal summation of x to the n equal to 1 over 1 minus x.
Geometric series.
No. Just
Taylor
the
series.
no. Right now we are talking about the power series. The most well-known power series is 1 over 1 minus x. The function first represent the function, which will represent function, and the second one is natural log of 1 minus x, which is x to the n over n, and that's the second one. Taylor Maclaurin is general expression. You had to memorize this because I will ask you that. Lastly, there are 3 more that we're gonna talk about Monday. It's probably about a TikTok. It's probably, I don't know what is it, but it's actually interesting. I'm still building that Desmos up, but anyway. Monday we're gonna teach you how to apply Taylor series and Maclaurin. Probably Maclaurin rather than Taylor, because Maclaurin is very easy to use. And then you're gonna do find out the power expression of 3 different functions. One is e to the x. Second one is sine to the x. And third one is cosine of x. So this 3 power series or Taylor series of this, you have to know. You have to know that. But we're going to talk about it Monday. How do you get those using Taylor series? How much time I have? Okay, I don't have enough time to do e to the x. If I have time to go to e to the x is fairly easy. So you have no homework, but make sure you understand ratio test and convergence test of intervals. And that'll be all. Shout out to Xavier, Andrew for not showing up to school. And Emily is in regional. Good luck in regional. Who else? Dapper didn't show up last period. Who else?
Why did Xavier not come
Xavier is probably have some music event. He has an audition or something.
in? Excuses. I don't see school. Have I ever skipped a class?
Do you have audition?
I think I've had perfect attendance.
Do you have audition?